Okay, guys, this is kind of lesson for anticipating the paper 3 questions, which is on next Tuesday, coming Tuesday, based on my gut feeling, not no other things, just my gut feeling. Okay, the first question I am expecting here is the differential equation together with the series, together with the Maclaurin series. The As you may know, this is retake, right? So that I have the question which I found just before. I will use that question paper to explain this question. Hold on, let me get that question paper. Where is it? Oh yeah, this one. The question number is number 70 from my past paper collection book. Number 70 of the option past paper book. So the first, okay, they will give you the differential equation like that. From this differential equation, first my expectation is, okay, they ask you to use Euler method to find a approximation the solution for certain x value, right? I don't want to go over this Euler method at this moment, but you should be able to do this with your calculator. If you don't know how to do yet, then please check with the YouTube. There is a lot of examples you can follow Euler method, right? The second thing is we can go over directly the derivative from this differential equation to get the second derivative, third derivative, and then blah blah blah. So for example, when dy dx plus 2x minus 1 y goes to be 0, we go for the implicit derivative directly from this differential equation, which is 2y plus 2x minus 1 dy over dx goes to be 0. And then go for one more step, then third derivative plus 2 times dy over dx, and then plus 2 times dy over dx plus 2x minus 1 times d squared y dx squared goes to be 0. Together that is 4 dy over dx, right? And then if they are asking up to the fourth derivative, then yeah, we do one more step of derivative, and 4 times dy dx goes to be 4 times d squared y dx squared plus 2 times d squared y over dx squared plus 2x minus 1 dq, and then together there is 6 d squared y over dx squared. So that we have all the things. In order to construct the Maclaurin series, when x is 0, the question gave you the initial condition y is 2, right? So that we know y is 2. And then dy over dx we can calculate from here, right? X is 0 and the y is 2. Once we plug this, then dy dx goes to be 0. Then this is minus 1 and then 2, so that there is 2. So that we can say there is 2, right? Second derivative, okay, from this equation, x is 0, y is 2, dy over dx goes to be 2. Then we plug everything. This one goes to be 8 minus 1. Then this one, oh no, we need to calculate from here. Sorry, x goes to be 0, y goes to be 2, dy dx goes to be 2 as well. Then this one is 2 times 2, 4 minus 1, 2, 2 minus 2, right? So that d squared y over dx squared goes to be minus 2. Here we put minus 2, then this is 8, and then minus 1 times this one is minus 2 plus 2, 8, 10, so that d cubed y over dx cubed goes to be minus 10. And then we can plug everything here, then x is 0, y 2, y prime 2, y2 prime minus 2, y third derivative goes to be negative 10. We plug everything, then this one is minus 12, and then this one is minus 1, and then this one is minus 10, plus 10 minus 2, so that y fourth derivative goes to be 2. D squared y over dx squared goes to be negative 2, negative 10, fourth derivative is 2, then your y goes to be, your fx, okay, goes to be 2 plus 2x, and then plus minus 2, 2 factorial x squared, 3 factorial minus 10 x cubed, 4 factorial 2 x to the power of 4 plus blah, blah, so that we can construct the so-called Maclaurin series of the fx, right? Yeah. After that, they can ask you to compare this Maclaurin series together with the result from the Euler method. And then exact solution. You need to solve the differential equation directly. There are 3 different methods, right? Separation variable, and then third one is integrating factor, and then here kind of the modification of separation of variable, homogeneous one, right? So the final question can be, yeah, compare those 3 different widgets. It could be there, I think, right? Okay. Another question can be something like this. This is very common. Find the Maclaurin series of sine inverse. How to find the sine inverse Maclaurin series? Do we need to do the derivative all the way down? No. Actually, once we go for the derivative of sine inverse x, then it will be something like this, right? And then this one is 1 plus minus x squared to the power of negative half. Then we can go for the expansion, the Maclaurin series, power series expansion, binomial expansion, extended version of binomial expansion, whatever, yeah, name is there. But anyway, we know how to expand this into the Maclaurin series. That is 1 plus negative half times minus x squared plus 2 factorial negative half negative 3 over 2 x minus x to the power of minus x squared plus blah blah blah, right? Then how we can get the fx? Fx is integration of f prime x, so that we should have constant, right? And then we can integrate these Actually, if I simplify this one more time, then plus 4 8, then there is x plus 2 6 40, and then we know f0 is 0 because fx is sine inverse x, right? That's why c goes to be 0. So that fx is x plus 1 over 6 x to the power 3 plus 3 over 40 x to the power 5 plus blah blah. About the series, this is another question, okay? Series can be combined together with the integration or sometimes derivative. That is also possible. Another example, similar example, is about tangent inverse x. How to make the series of tangent inverse x. Once we go for the derivative, there is 1 over 1 plus x squared, which is 1 plus x squared to the power of negative 1, right? And then we can go for expansion, binomial expansion. Those kind of things are there. And then another two more example can be, one is the composite function says like e to the power of sine x or something like that, right? And then another one is the series, no, division. For example, fx is e to the power of x over sine x. What is the series of this one? Those kind of questions, yeah, can be there. You can check with the textbook, I think. So I think there can be such a question like the Maclaurin series combined with the differential equation, and then Maclaurin series calculation like the division, multiplication, composite functions, the Maclaurin series. Those kind of things can be combined together to get one very big question. That's my first expectation. I'll take another shot, which is for second anticipation. Okay, this is the first my anticipation.